The title of my presentation is Asymmetry and Neutralization in the Sylheti Phonemic Inventory. The contents are as follows. So the first section is the introduction, which basically I talk about what got me interested in this topic. Next, I discuss the theoretical background, where I discuss two models of what shapes the principles that shape phoneme inventories. In the third section, I discuss asymmetries in the Silhetti inventory. And then I try to analyze that using the notion of feature economy in section 4, where I also look at economy in the inventories of Indo-Aryan languages, which are related, and as well as neighboring Manipuri and Naga languages of Sylheti. And then I give an analysis of the changes that the Sylheti inventory underwent, and then I give an OT analysis of that, and last I discuss some residual questions and the conclusion. I begin with this quote from Ladefoged, where he says, "Sometimes these contrastive units are not as discrete as one would wish in an ideal linguistic world." As phonologists, one of our main tasks is to sort of divide the speech stream into discrete units, which we call phonemes, and fix them basically, even though Ladefoged in the same paper discusses how based on contextual factors, they can vary quite a bit. What we call one phoneme can vary quite a bit from one environment to the next. So this is what got me interested in this topic. The theoretical background is basically, Bersama in his paper on the functional analysis of consonant inventories states that there are three principles that drive the development of any sound system. The first is maximizing ease of articulation. The second is minimizing confusion in the vocabulary by maximizing perceptual distinctions between words. That is, we want to reduce homophony in the lexicon. And the third is the grammar tries to increase the perceptual salience within words. That is, adjacent sounds should not be similar to each other, so a dissimilating force. An example of these type of forces driving sound change is this Germanic consonant shift, which Bersama quotes Schmidt's account of, where basically he describes how per changes to fur to the voiced fricative ver to bur and then back to per, based on different kinds of articulatory ease, such as, for example, maintaining voicing is difficult, so you change back to the voiceless, or spirantization in an intervocalic environment. So these kind of shifts can happen for local reasons, and then they give you these kind of patterns. Another model that was really convincing to me was Lindblom and Madison's rubber band model. They based this study on the UPSID database of 451 languages, and what they basically found was that there are three sets of they divided the consonant sets into three sets. The first is the basic articulations, which includes plosives, fricatives, nasals, and sonorants. Set 2 is the elaborated articulations. So these have more complex segments, which are harder articulatory, such as breathy voice, phonation, aspiration, retroflexion, etc. And the set 3 is complex articulations, which basically combine two or more features from set 2. So what their model basically proposes is that the consonant inventory, when it's sort of shaping itself, is like a rubber band, and you have these neutral articulations, which is represented by this black dot in figure 2, which are the most unmarked sort of sounds. So for example, Pertaka would be an ideal example of a neutral articulation set. And then you have magnets, which are these uh, white dots, which basically are the force towards perceptual distinctiveness. That is, you want sounds to be maximally different from each other. However, consonant inventories don't behave like vowel inventories, which prefer maximal dispersion. Instead, they follow this subspace saturation, which is, if you have a particular feature in your language, you would prefer to use that you would exploit it to the maximum to create the set of sounds, and once that set is exhausted, only then would you move to some other feature to increase your phoneme inventory. um, yeah. So now I move on to the consonant inventory of Silheti, which is an Eastern Bengali dialect. So in Silheti, we have a very interesting pattern which goes against the predictions of markedness theory, which would predict that if there is a neutralization, you would try to neutralize the marked counterpart of a sound. So, but we see in Silheti, in the plosive set, in the labial and the velar, the voiceless plosive and the voiceless velar per and ka are missing from the inventory because they have undergone spirantization. Another important point to note for my presentation for this paper is that Sylheti also had a de-aspiration rule where all of the aspirated counterparts have been lost in the language and have been replaced by spirants. So in Sylheti, basically there is a merger of the voiceless uh, sorry. There's a merger of the bilabial and the velar series where the plosive uh, where the aspirated voiceless and the unaspirated voiceless are replaced by a corresponding spirant, and the voiced counterparts are retained, though they are also deaspirated. So I formalized these as two rules in 1 and 2, the deaspiration and spirantization rules. Now this gets more complicated when we look at the velar set, because we also see that velar plosives are preserved in certain contexts, such as preconsonantally or follow in the context of this high front vowel E. And this, I have argued in a previous paper, is a synchronic rule of photition, although it might also be a blocking of the spirantization rule in these contexts. So that analysis is also possible. So here we have the current Silheti inventory, and again, like I call attention to the fact that it's highly unusual for a language to use two mark feature values, plus voice and plus continuant, to contrast two sounds when a single feature voice would have sufficed. A per bird distinction would have been much easier and less costly for the inventory than a fur and bird distinction. Uh, yeah. So now I analyze this sort of inventory restructuring using Clemens's uh, 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 tool of a feature economy index, which is basically given over here in 5. It's a very simple formula. The economy of an inventory is the number of sounds divided by the number of features. While counting the features and calculating this value, we only look at active features which are lexically distinctive or active in phonological processes which may be non-distinctive, so allophones also are counted. It applies to both single-valued and binary features. So single-valued features include things like labial or dorsal, and binary features like plus, minus voice, and only the mark values of binary features are active, are counted basically. So, for example, only plus voice would be counted. So feature economy tends to reduce perceptual distance among sounds because it basically forces the inventory to maximize the use of the features for maximum number of sounds, but certain feature combinations which are universally marked, like voiceless sonorants due to articulatory difficulty and the pressures on the articulatory system are universally avoided by all languages, even though they would lead to greater economy. So in this table, I have calculated the feature economy of uh, various Indic languages. So starting with Old Indian Aryan, Old Indo-Aryan, Middle Indo-Aryan, then uh, New Indo-Aryan, which have retained the aspirated series completely, or which have a complete aspiration and voicing distinction. So standard colloquial Bangla, Assamese, Nepali. Another set of languages which have lost the aspiration distinction partially. So these include Bangladeshi, which has no voiceless bilabial plosive, Punjabi, which has no voiced aspirated stops, but it does have voiceless aspirated stops. Um, and I've also uh, calculated the inventory of some neighboring languages like Bodo, Ao Naga, and Nagamese. Um, and I've also included Sinhala because it's another similar case to Sylheti where all of the entire Spirant series has been lost. So I've given the representation of the economy. So this green line represents the number of sounds, the blue line is the number of features, and this yellow line is the economy index. So as we can see, the number of sounds can vary greatly between languages. The number of features also varies, but as you can see, the economy index is more or less stable with some variation between 3 to 1. Another point to note, sorry, I forgot to mention this, is that the higher the economy index, the greater is the economy of that particular system. What we basically find out from this analysis is that a language like Vedic Sanskrit, which has been described and as having a very complete set of feature exploitation. So the voice series, the aspirated series are all complete in all places of articulation. The nasal has 5 places of articulation as well. Sibilants have 3 places of articulation. So it's a very complete inventory in that sense, but there is, as we can see from here to classical Sanskrit to the Magadhan languages, which I've taken as the Magadhan Prakrit, which I've taken as a representative of Middle Indo-Aryan, there is a drop in the number of sounds. So this, I argue, is due to the difficulty of uh, articulatory due to articulatory difficulty and simplification also from a perceptual standpoint, because if the sounds are too close to each other, then it would be difficult for speakers, for listeners to distinguish between them. Uh, Languages like Punjabi and Sinhalese that have lost the aspiration contrast have still managed to keep the economy index high by creating new series that utilize extant features. For example, Sinhala has a voiced stop series which is pre-nasalized, which is unique amongst the Indo-Aryan languages. Uh, yeah. And in the case of Bodo, Ao, Naga, and Silheti, their economy is relatively quite low compared to the Indo-Aryan languages. But this figure does not account for tonal contrasts that exist in these languages, which maximize the contrasts available to speakers. So I propose that we include tonal contrast as a distinctive feature in the inventory. The Silhetti neutralization processes. So I propose that this is the chronology of the Silhetti sound change, which I discussed earlier briefly. So at first there was a loss of aspiration, It has been argued to be articulatorily costly and is often lost in related languages like Bengali, Assamese, Hindi, in less salient positions like the word final or coda position. Uh, so this created uh, a floating laryngeal node, which basically I argue could have led to the tonogenesis that Professor Gope has described in his thesis. So this is the representation of the sound change for labial stops. So as we can see, we have b and f here as the final sort of output, as well as b with the tone. In the case of the dorsal series, it's much more complicated. So we have tonogenesis as well, we have spirantization, and we also have some contextual photation or preservation of the plosive. So for the OT analysis, the constraints used were the following: a star aspirate, ident continuant, ident manner. Uh, this constraint number 9, star PAA, is based on Kingston's work, which basically is a spirantizing constraint, which says that any plosive preceded or followed by a vowel gets a violation mark. So table 3, 4 and 5, table 3 and 4 show de-aspiration, since aspiration is ranked high in this language. Table 5 shows that B is preserved, it doesn't get devoiced or spirantized. Table 6 shows the spirantization because ident grave is ranked lower than the spirantization constraint. Table 7 shows the same thing for the labial. Table 8 shows the de-aspiration and spirantization of the labial. Table 9 for the velar. And table 10 shows the retention of the voiceless velar plosive. This is because no, I'm sorry. So this is because ident continuant grave is, although it's rated lower than these two constraints, it is still phonologically active. So that is why kin is not a acceptable form. And this table 11 shows that even if the input is the obverse with the spirant as the input, we still get the voiceless plosive. So I'll just move to the conclusion. Yeah, so the introduction of a new sound in a language could be due to chance factors such as contact, and these are unpredictable, but the response of the language system and its reorganization follows universal principles which we have formalized in the study using markedness and faithfulness constraint. We analyzed the de-aspiration and spirantization processes in Sylheti, which led to a reorganization of the phonemic inventory. And we also demonstrated how contrasts are preserved in the most unmarked place of articulation, as well as the most partially preserved in the most marked place of articulation, which is the dorsal. Residual issues, there are some morphological interactions in the retention of the velar plosive, which needs to be looked at in more detail. Yeah, so these are my references. Thank you.
I have a few suggestions. You may actually like to look at my paper, 2018 paper, and then the one that I recently got published, 2021, the tonogenesis part.
Okay.
So both the things you need to look at. 2015 one, like the phoneme inventory might not be a good one to include there. You should go for 2018 one possibly.
Okay.
I would be skeptical about not only the velar one, but I would also go with the labial. the labials also, I mean, both the labial and the velar, both would actually retain their, uh, plosive forms, okay, in front of the high vowels, E, O, both. Okay, so whenever they occur before a high vowel, they retain that, form. So the table like 10, 11 didn't look like very conclusive for me. You have
Okay,
to relook,
yeah.
right? You have to relook into it. And did you include any nonce word? Because table
Yeah,
number,
these are nonce. I
yeah,
mean, they're,
I,
yeah,
I hope so. So actually, you can include like proper words
yeah.
as a
I'll do
reference
that.
point. As a reference point, you can actually. I mean, I don't know how you are starting. I mean, if I have to start, I will start Silhetti as a single. I mean, individual language, independent language, regardless of standard Bangla.
Yeah,
So, um,
yeah. I'm looking at it from that
angle,
perspective.
right? Yeah.
Yeah,
And in the feature geometry, feature economy, I think you need to include the null contrast because they do, uh,
yeah, yeah,
right? So, of course, for Bodo and Silhetti, without the null contrast, it looks like 2.5. But then if you include,
yeah. It will go up to
it
3.
will go up, right? And then the third thing, we are doing a reanalysis, of course, now, and I think we need to. I actually have to reserve myself about the number of tones. It could be actually more. I indicated about the possibility of a third tone, which Shakuntala
Yeah,
and Priti they felt that there is a third tone depending upon the the occurrences on the onset position or the coda position. But I actually think there could be more situations which I am looking at at the moment. So
okay.
all those things, the numbers would be a bit. Maybe you can actually get in touch with me after a
Yes,
month or
sure,
so.
sir.
So
Yeah,
I'll be able to tell you exactly the kind of null contrast that we are exhibiting at this moment. It's a continuation process, and then you see when I started there was no work, right? After that, lot needs to be done.
yeah.
After that,
I
lot
mean,
needs to
my
be
work
done.
is based on your work, so
Yeah, so no, I'm happy so many works are going on here. We can discuss. So these are some of the observations, Ankita, which you can actually keep in mind. I know
yes,
it's
sir.
a work in progress. We are still developing on it, so we
Yes, sir.
can just include those
I'll
things.
definitely write to you very soon.